Okay, so my name is Chris Exley. I'm at Keele University. I work on aluminium. Essentially, I work on aluminium and silicon. But that's what I do. But today, I've been asked to talk about just one particular aspect of it. So that's what I'm going to do. I'm struggling a little bit with a small chest infection, so every now and then I may just stop for a drink of a very important mineral water. And maybe we'll find out why it's so important later. Okay, let's have a look at a few hard facts about aluminium adjuvants. As it says here, I came into the field of aluminium adjuvants perhaps only 10 years ago. I don't know why. I'd already been working on aluminium for 25 years, and it suddenly crossed my mind that we use aluminium and aluminium salts every day in almost every individual, and have done for decades. And for some reason, this had not crossed my mind that this was a form of human exposure to aluminium. And we started to look at it also because the great and the good of immunology were writing in Nature and Science and other reputable journals how aluminium adjuvants work. How is it that they boost the immune response? And when I looked at this, I thought, that's not how aluminium works. You're not right. And there were a lot of problems with what they were saying. And they're great immunologists, but it seems like they thought a little bit like when we first chose to use alum as an aluminium adjuvant. It's just something you can take off the shelf, put in something, it works, and therefore it's okay. So I believed, at least in the early days that we started to look at this, and I'll take you through a little bit of a whistle-stop tour of the last 10 years, that if nothing else, that because an aluminium adjuvant was in a vaccine, that it must have been shown to be safe before it was used, that the adjuvant itself would be clinically approved. Apparently not. What is approved is the whole vaccine. And of course, if whole vaccines, including aluminium adjuvants, had been shown to be safe using a true placebo, such as saline, we probably might not even be having this conversation today. Probably because they would no longer be being used. Because more than 90% of safety trials for vaccines with aluminium adjuvants have not used a true placebo. They have used either the aluminium adjuvant itself, something, a placebo is supposed to be something which will do no harm, do no damage, be inert. Aluminium salts are far from that. The reason they work in a vaccine is because they are not inert. So, why is that the case? I asked the question. Perhaps one of the most controversial areas, and it absolutely should be an extremely controversial area in the HPV vaccine. The placebo was a proprietary aluminium adjuvant. I even wrote a small letter to one of the Lancet, this is a vaccine, actually, a vaccine journal, just saying, what's going on here? How is it that nearly all vaccine safety trials are using aluminium adjuvants or another vaccine which contains an aluminium adjuvant as the placebo? They know what they're doing, by the way. They're not stupid. They know what they're doing. This is not an oversight. After I had this published, everything didn't change. Nothing changed. So our approach to this has always been, I am an aluminium man. This is why I'm in this subject area. The only reason, because my life is about understanding aluminium in living things. So our approach is always to be as fundamental as possible in the first instance. And the reason why the great and the good of immunology were wrong about how an aluminium adjuvant works is that they had no understanding of the inorganic or bioinorganic chemistry of aluminium salts. He had no understanding of what happens to an aluminium salt when you put it inside a human being. So this is how we started, and this is just an example of papers, etc., trying to understand what happens with an aluminium adjuvant when you have it in the whole vaccine, in the vaccine, and then you inject it, for example, into the muscle. So which aluminium adjuvants are we talking about? Well, the most common aluminium adjuvant is one called Al hydrogel. It's an aluminium oxyhydroxide. It's actually quasi-crystalline aluminium oxide. And you can see it's actually composed, in terms of its primary particles, you might even call it a nanoparticle, because it is in the nanoparticle size range. And as it says here, it's the most frequently used. The second, perhaps most frequently used, is called Adjuvos. This is an aluminium hydroxyphosphate. This is an amorphous aluminium salt. So remember, Al hydrogel was semi-crystalline, therefore a little bit more inert. Amorphous aluminium hydroxyphosphate is more likely, probable, that when it goes into a biological environment, it will dissolve more quickly. It will dissociate and dissolve. It is also probably just in the field of nanoparticles as a primary particle. AAHS, amorphous aluminium hydroxyphosphate sulfate, no one knows anything about this because Merck will not allow anyone to look at it. This is Merck's proprietary aluminium adjuvant, perhaps notoriously used in Gardasil. We've asked them several times. You know, we're pretty good at aluminium chemistry, so we know probably why they're not letting us look at it. And most of you out there who remember a little bit of, even if it's only your school chemistry, will know that sulfate is an acidic anion, acidic salt. So the likelihood is that this particular aluminium adjuvant is going to create a different environment at the injection site, perhaps more acidic, almost certainly a form of adjuvant which is going to be more easily dissolved. It's going to probably be more toxic at the injection site, which is the reason why it is used in order to get the antibody titer that they need for these antigens. These HPV antigens will not produce anything on their own. They need something else to stimulate the immune response significantly before you get any response to them. And that's why they've chosen a proprietary adjuvant, which they've never let anybody else look at. And, you know, there's a reason for it, and that's because they needed to get this increased toxicity at the injection site. How do they work? So that's the first thing. We're not interested initially on the aluminium adjuvants being bad. We wanted to know how do they work. And to know how they work, we've really got to look at, in the first instance, what happens immediately upon their injection. This is a paper I put together for Trends in Immunology as a response to the great and the good. You can imagine when I tried to publish this, I did get quite interesting reviews from some of these people who didn't want it published. But we got it published because the editor of Trends in Immunology recognized the quality of the work. It's not always the case that you manage to get something published based on the quality of the work. So the area we're going to look at just now is this area. This is the injection site. And there's no need to read all of this. All it's telling us is this. It's a really diverse and complex chemistry once an aluminium adjuvant is injected into the body, into the injection site environment. Actually, the adjuvant preparation or the vaccine preparation itself, when you inject it, to begin with, it is most of the volume. So you're not putting a vaccine directly into a flowing blood situation. You're putting it into a situation where You have got some tissue damage, you've got some damage of vessels, you will have infiltration of blood and other fluids. But in the first instance, it's more or less sitting in its own environment that it was in the jar before it then starts to mix and dilute with the body fluids. Apparently this is one of my workers has done. Oh yeah, there we go. I stole this slide. You saw the two names at the start, Emma Shardlow and Matt Mould. These are the two great scientists who work with me who do all this research. I'm just the person talking about it. So in the jar, before it gets injected into you and me, although I only had 3, I'm 55, we only got 3 vaccines. Today, a child before they're 18 years of age will have approximately 40, 45 vaccines, the vast majority of which will include an aluminium adjuvant. So I'm going to go over this quickly because it's just the important information to come from it is that, so in the actual bottle, the vaccine bottle, and we look at the size distributions, the point of this is just to tell us that these 2 aluminium adjuvants, and this one called Imject Alum, which is not an aluminium adjuvant anyway, it's an antacid, but most people who did research on aluminium adjuvants before I got annoyed about it, all used this as their aluminium adjuvant in all of their studies that were published in Nature and Science and everywhere else. It's not. It's an antacid. It's completely different in every single way. But of course, it's an aluminium salt, so they're all the same, aren't they? But what we can see here is that we've definitely already got significant differences in the particle size. Now, it's no longer a nanoparticle. Don't get hung up on nanoparticles, by the way. The world is hung up on nanoparticles. Nanoparticles are not an issue. And in this instance, what happens with most nanoparticles, all nanoparticles, is that once they hit a biological environment, if there's enough of them, they want to be together, and they aggregate, and they form much larger particles. So now we're seeing particles that are a micron in size, several microns in size, formed from those primary particles. And this is just a little bit more data showing that we get very different results in terms of, for example, the particles that are less than 2.7 microns for AL hydrogel in the order of 80%, but for Adjuvos down to 35. Now that's important. The size is important because we'll see in a minute. The size is important because when an aluminium adjuvant is at the injection site, the next step is that it has to be taken up by an infiltrating cell of some sort in order for it and the antigen to be taken off to the lymph gland in order to instigate immunity and immune response. That's what AL hydrogel looks like on the electron microscope in saline. That's what Adjuvos looks like in saline. This is one worth just quickly noting. So what is the charge on these aluminium salts? The overall charge, are they negative or are they positive? AL hydrogel is positively charged. Adjuvos is significantly negatively charged. So that, of course, is going to influence how things stick to them. Of course, we're told that the antigen must stick to the adjuvant, and then that gets injected in order for all of this to work. So you can imagine that if you've got something which is positively charged, something which is negatively charged, you're going to have significantly different antigens in order for that sticking process to even work. I think what happens then, so this is, take that bottle that we've just shown a very brief characterization of. What happens to those aluminium adjuvants once you put them into the muscle? I think there might be another animation here. Oh, yeah, there it is. And there it is in the muscle. I take no credit for this. Already we see some big changes here. We see the particle sizes changing within the muscle environment. Again, with the AL hydrogel, we're around 1 micron. It starts to aggregate even further within that environment over time. And again, using the same sort of principles as last time, we can see that, again, in this time, we start to see a change in the fraction, which is less than this particular value. And after 24 hours, a big change. So these adjuvant materials do stick around at the injection site, and for varying amounts of time. And we could be talking days, and in particular condition, which I'm not going to talk about today, called macrophagic myofasciitis, there's evidence that they can stick around for years at the injection site. So AL hydrogel in our version of the muscle interstitial fluid looks a little bit different, but that's what it looks like on the TEM, transmission electron microscope. Now, that's something different, because AL hydrogel in the bottle, before it's injected into you, was positively charged. It will immediately assume a negative charge at the injection site. So already you're seeing a change, a significant change in its property, simply by the fact that it's now inside you. Adjufos, this is the hydroxyphosphate version of the aluminium adjuvant. Again, we're seeing particle size. Remember last time it was slightly larger than AL hydrogel. It remains slightly larger, but not much larger. So they are actually coming together. Once you're in a biological fluid, the two aluminium salts look similar in terms of their particle size. And by the way, I don't know what the situation is, Damien and Shida, but I'm quite happy for these slides to be made available to people after the meeting. So don't worry about trying to take pictures or things down, because there are some nice links I put on them for you as well. So again, looking at Adjufos, we can see a change. Particularly, let's look at this one over time in this particle size. Now, the reason I keep looking at this one is because we're going to see that this particle size is actually the critical particle size for them to be, for their particles to be actually taken up by cells infiltrating the injection site. We're probably going to see that it's actually closer to 1 micron. So this type of cells that come to the injection site, and we'll see some of those in a minute, that are able to take up aluminium adjuvant can only take up particles of about a micron size or less. But the vast majority of the adjuvant is much bigger than that. We're not sure whether these cells actually bite off bits of adjuvant or not. But there may just be that there's enough adjuvant in the small particle range for that not to matter. Adjufos in the TEM, again at the injection site. And now Adjufos doesn't change its charge once it gets into the body. And probably the reason why AL hydrogel did change charge is because within the fluid in the muscle interstitial fluid is a high concentration of phosphate. The phosphate can then adsorb onto the AL hydrogel, giving it a negative charge, but it doesn't on the hydroxyphosphate because it's already there. So they both have very similar charges once they're in the injection site. So the conclusion's just about this characterization part, and this is important because it's going to tell us about the biology that we'll look at next. So in the sodium chloride, negatively charged Adjufos, larger overall particle size than the positively charged AL hydrogel, and this is the difference here. At the injection, both become negatively charged. After administration or injection, AL hydrogel has higher abundance of particles available for phagocytosis. So we've got two aluminium adjuvants. We've sort of followed them from the bottle into the injection site, and we've seen what happens to them in terms of how biology can then work with them and react with them. This is the moment where I'm going to have a little bit of this very special water, but there are other brands available. I'm sorry, but I actually really am suffering a little bit. And I have been since like September. There's something really nasty about it at the moment, I think, and it seems to be affecting our lungs. So what about the cellular response? In other words, what is actually happening in terms of after the injection of the aluminium adjuvant and the antigen, what happens next at the injection site? So this is, of course, the critical part in terms of both understanding how an aluminium adjuvant works, and also, as I may have mentioned previously, what has come to light, or came to light for me in the early stages of researching these areas, and before, what I'm about to tell you I did not know when I started to research these areas, was that quite a significant proportion of individuals who receive a vaccine suffer quite a serious adverse event, either immediately afterwards or within a period of time afterwards. Not just the little red mark, or maybe a little bit of a stiffening of the arm that you may feel, but serious adverse events. Included in that definition is death, by the way. So some of what I'm going to talk about now are on these. This is a recent review we've just published in the last few days, and these are some primary articles here that you can get from the slides later. So we use a particular cell line called a THP1 cell line, which is a monocyte, which is essentially a very good model of the monocytes that come to an injection site. So we're doing all of these studies in vitro, in cell culture systems, in order to understand what we need to do. This is not the type of thing you can do in humans, and I don't like to work with animals. And I'm not sure that working with animals is going to tell me anything anyway. So when I can work with humans, I do, but not in this type of experiment. So what do these cells look like? Okay, so a THP1 cell is rather interesting. What I'm showing you here is I'm going to show you a method that we developed using fluorescence microscopy to unequivocally identify aluminium, whether it be inside a cell or inside a brain tissue. And I'll show you some of those too. This is a THP1 cell that's had no exposure to aluminium adjuvant, but it has been exposed to the fluor that we use to identify aluminium. And the cytoplasm of the cell gives a sort of dull orangey type color. DAPI staining, some of you will know, stains the nucleus. So we use it to show the nucleus of these particular cells. And rather interestingly, I hope you can see here, these THP1 cells have a huge nucleus compared to everything else. So the cytoplasm is relatively small compared to the nucleus. So if we then expose these THP1 cells to aluminium adjuvant, what do we see? No. First I'm going to just say, what does the THP1 cell look like under the electron microscope? And that's it. There's its nucleus, and there's its cytoplasm. Actually, it's so easy putting these slides on, but I remember Matt Mould having to develop a method simply to be able to harvest these cells and be able to fix them in a way which enabled him to do not only fixation for fluorescence microscopy, but even more complicated, the fixation for TEM. It's not a trivial thing to do, but that's a beautiful image. So what happens when we expose to AL hydrogel? So immediately, I hope, and what we can probably, these are different concentrations of the aluminium adjuvant. Actually, 100 is still like a fifth of what any normal vaccine would include. But if we use the actual concentrations of aluminium adjuvants in vaccines in these preparations, all we will see is a great mass of orange. We'll see nothing else. It totally occludes all the cells. So we need to, in order to see what we want to see, we use lower concentrations. But I hope you can see that what happens very beautifully, actually, is that these cells load up. They load up their cytoplasm with aluminium. Look at this. They really, in the case of AL hydrogel, it appears that they do that at all four of these concentrations as well. And, as we'll see in a minute, these cells appear to be pretty viable, remain viable, even though they're loaded up. with aluminium AL hydrogel adjuvant. I didn't know I had a blank slide there. Probably because I wasn't the first person to prepare these. This is, yes, there we go. This is going to be a quick summary of what I've just told you based on the different concentrations. So, you know, the interesting thing which I mentioned previously was this bit here. We were able to look, and I think I can show you some images of that now. So this is a TM again. Here is the AL hydrogel inside a vesicle. And you can even see the vesicle membrane here. These are 1 micron in size. So the AL hydrogel is internalized by endocytosis, the process of the membrane going around the aluminium adjuvant and taking it inside the cell, inside a vesicle. And we measured about 100 or more of these vesicles, and they're all the same size. They're all approximately 1 micron in size. So it might sound trivial to you, but this is important because this is telling us a little bit about how these cells are actually using or in any way, you know, taking up or metabolizing, however we want to call it, the aluminium adjuvant. They are not taking up the great huge particles, and there's no evidence of anything smaller. Everything is inside a vesicle. Now, Adjufos, I mentioned previously, is that more soluble form of the aluminium adjuvant. And this is important again because when it gets into the injection site, it does clearly, from what we've seen, dissolve more easily. The result of that is you see a lot more bright orange, which is aluminium everywhere. And also we see that in the lowest concentrations, we see exactly the same. We see beautiful loading up of the cytoplasm with the Adjufos. But at the higher concentrations, we actually see less of that. And we'll probably see in a minute why that probably is the case. But first, I probably have to go, yes, through an animation I wasn't expecting. And here it is. And here's our little conclusion. But interestingly, again, with the Adjufos, we're still talking about internalization inside, and I'll show you pictures in a minute, inside the endosome that's been taken inside little vesicles of the endocytic process. This is something we only saw with Adjufos. And the reason we're showing you this is, remember that blue DAPI staining is for nuclear material or nucleus. Well, actually, in these preparations where you expose THP1 cells to Adjufos, you get lots of loose nuclear material in the medium. It tells us there's cytotoxicity. It tells us that that's being released from the cells. So Adjufos, and we'll see some data from it in a moment, is significantly more toxic, cytotoxic at the injection site than AL hydrogel. And there's another image showing, this is your Adjufos, and here's the nucleus. And I think, again, yeah, sort of similar here, but we're always talking about, look, 1 micron is here. We're talking about it being within vesicles, always around that 1 micron in size. So what about the toxicity? I just mentioned it. Oh, we've got another animation. Oh, that's even better, isn't it? It's gone. And very quickly, you've got the colors here are AL hydrogel and Adjufos. And you can very quickly see one is much more toxic than the other. So that's important. Why is it important? You know, how does an aluminium adjuvant work in the first instance? It causes toxicity at the injection site. That's how they work. And this is one of the things that the vaccine manufacturers have to be very careful about. Because in vaccine so-called safety trials, there is only observation of the patient for a very short period of time. Adjufos is not used anywhere near as much as AL hydrogel because Adjufos really can produce some rather nasty reactions immediately because of its increased solubility, therefore greater ability for the biologically reactive form of aluminium, Al3+, to produce cytotoxicity. So unless they need, for some reason, high toxicity to get high antibody titers, they go for the more inert Al hydrogel, inert at the injection site. But remember, the THP1 cells load up with Al hydrogel, load up their cytoplasm at the higher concentrations of the adjuvant, and they remain viable. This is the research we have ongoing at the moment, is to say, how long are these cells viable, able to do their normal function? How long do they remain viable once they're loaded up with aluminium adjuvant? Okay, thanks. So this part, 2 aluminium adjuvants used clinically approved vaccines, cell cytoplasm only. We say that because there's an awful lot of research that suggests that aluminium goes into the nucleus. Well, it's not the case for aluminium adjuvants, that for sure. We never see it there with our very carefully and specifically designed method to do so. And we know that the adjuvant is more toxic, for one reason, the release of the extracellular material, but also from the cytotoxicity trial that we've done. Okay. I've said that. Now, this is perhaps the important bit that I may not have already said. Because if a cell comes to the injection site, loads up with aluminium, and remains viable, that cell can go anywhere else in the body. And with it, it can take its cargo of aluminium. Clearly, that's one of the ways in which we expect aluminium adjuvants to work, because they enable the transport of aluminium, or the adjuvant and the antigen, to the lymph nodes. And to do that, a cell is taking them there. In relation to lymph nodes, actually, there is no data for humans at all about transport of aluminium adjuvant to lymph nodes of humans following vaccination. However, my colleagues who work on sheep, and one might think, sheep, it's a sheep. Or in the Spanish, sheeps. However, this beautiful piece of work, because there is a problem in Spain with over-vaccination of sheep, which produces a syndrome. When they did beautiful experiments in sheep, where they essentially gave sheep whole vaccine, or aluminium adjuvant only, or saline, and we were able to then look at where the aluminium adjuvant went. And we showed that it went to the lymph nodes. But in the whole vaccine, where you've got the antigen and the aluminium adjuvant, the amount of aluminium in the lymph nodes was was much higher than in the adjuvant-only preparation. So if you put just the adjuvant, like in almost all of the safety trials, the aluminium is not going to the lymph nodes, or the vast majority of it isn't, even though we know it's getting loaded up into cells. In the presence of the antigen, some synergism there means that much more aluminium goes when it's the whole vaccine to there. So you've got already a disparity in the way that the body deals with an aluminium adjuvant, if it's in the presence of a vaccine or not. Very important piece of work. The only time in any animal or human and any vertebrate where this has been shown. It's just been published in the last few days. And that's a conclusion based on what I've just said. So jump right ahead. Serious adverse events. What is a serious adverse event? Well, as I said, this is a continuum from a small red mark through to a brain encephalopathy in an infant, through to death. A few years ago, not many years ago, I was being told, in inverted commas, that there was a relationship between aluminium adjuvants, or aluminium per se, and autism. I had no obvious mechanism as to why that would be the case, and I believe that the literature that suggested that was, a long way from being, unequivocal. So what did we do? We had an opportunity, the privilege of looking at the only brain tissue available in the United Kingdom from individuals who died with a diagnosis of autism. And we had the opportunity to measure the aluminium content of these tissues. So this is something I've not talked about today, but we have measured the aluminium content of more than 100 human brains. And this is something we have a huge database on. So this was part of our human exposure to aluminium program, but perhaps it might have some relevance to the talk I'm giving today. It does. Why does it? So the amount of aluminium we measured in the brain tissue was really, really high. It really shocked me. But I was much more shocked by when we used the aluminium selective fluorescence microscopy to say, where is the aluminium? So quickly, in Alzheimer's disease, for example, when we find aluminium in human brain tissue in people who died with Alzheimer's, most of the time, most of the aluminium in the brain tissue we find sometimes associated with neurons, mostly associated with cell death, neuronal cell death, glial cell death, but pathology. When we looked at these autism brains, and we had 10 individuals where we did the microscopy on, in every case, we saw something completely different and completely novel we had not seen before. And that was that the aluminium was, first of all, almost always intracellular and almost always not associated with neuronal cells, but with the glial cells, for example, the microglia, the housekeeping cells of the brain. Or it was associated with lymphocytes, almost identical to the cells I showed you earlier, full of aluminium at the injection sites of vaccines. These lymphocytes are shown, at least theoretically, crossing the meninges from the lymph system through to the brain tissue. And there are examples here. I can't explain these at the moment, we haven't enough time, but these are the autofluorescence to prove that what we're seeing there is aluminium. Here we see another, almost exclusively within the vasculature now. We see, essentially immune reactive cells such as lymphocytes, in this case crossing the blood-brain barrier, potentially moving from the periphery into brain tissue, loaded up with aluminium. Now, none of this tells us where that aluminium is coming from. It simply tells us that when lymphocytes, when mononuclear cells which infiltrate vaccine injection sites load up with aluminium, one place they can go is into the brain. We know that these things happen in all types of inflammatory occasions where the brain suffers some sort of inflammatory insult. The brain, first of all, asks, and we can go to another slide now to look at what happens. Here's an example of probably some sort of inflammatory reaction. We've got some extracellular aluminium here, and it's surrounded by what are identified as microglia full of aluminium. So these types of immune reactive cells, you can get a signal from the brain to the rest of the body, come and help, we've got an inflammatory problem, and cells come from the rest of the body. And sometimes those cells are loaded up with aluminium, carrying a cargo of aluminium into brain tissue.
3 minutes.
Maybe I'm going to put that one on because it's very important to me, because this is where we talk about aluminium every 2 years, and we've been doing it since 1995. And the next meeting where we bring the aluminium family together, and you are more than invited if you're interested in this, will be in Mexico next year in March 2019. But perhaps we'll leave you with a more profound image. You know, I gave an interview directly after presenting this research for the first time at a conference in Paris. And I was extremely, succinct about it. before I saw this research, I saw no role for aluminium in autism. But actually, after we've done the research, I have to change my mind. I have to change my mind. And not only that, the inference that some of that aluminium could come from an injection site of a vaccine is incredibly strong. There are many instances where infants in their first few months of life suffer brain encephalopathies immediately following vaccination, and there is no explanation for that. These are going through the vaccine courts all over the world at the moment. There's no explanation. Maybe we have an explanation. Obviously, in the vast majority of infants and people, this does not happen. So we need to identify those people in which they are made potentially susceptible. What MELISA and other things are all about. Identifying groups of people who are most likely going to potentially suffer something of this ilk. This is scary stuff for me. And it remains so. And some of the comments on social media are also scary, because now I'm called an anti-vaxxer simply because I reported the science of aluminium in human health. Thank you very much.